Hello everyone, in this video let's discuss about Zener diode as voltage regulator. If you are new to our channel, please subscribe for more engineering related topics. So Zener diode. So this Zener diode is a heavily doped diode. Heavily doped diode. So let's discuss about what is doping. So doping is a process in which the impurities will be added to any semiconductor material. For example, let us take silicon. To increase the conductivity of the silicon, we will add some impurities, like it may be of the trivalent impurity, that is aluminum, which will be called as p-type. P-type semiconductor elements in which the semiconductor will be added with the trivalent impurity. Trivalent impurity means they will be having 3 free electrons. Next, it may be of the 5 free electrons, that is arsenic. It will be called as pentavalent impurity, n-type. So this, like, they will introduce the impurity semiconductors in order to increase their conductivity. So this Zener diode is heavily doped in order to increase its conductivity. Next, this Zener diode will work in breakdown region. So what is breakdown region? Now let's discuss it. When the voltage is increased in the forward direction, when the voltage is increased, then the current will grow up to a certain stage, that is up to threshold voltage. It will increase slightly. After threshold voltage, in forward biasing, it will rapidly increase, that is it will sharply increase. When the voltage is given the negative value, the current will slightly decrease. So this region will be called as the reverse bias region. At certain point, when the voltage, that is maximum threshold negative voltage, is given to the diode, then the current will rapidly decrease. So this region will be called as the breakdown region. And the current in this breakdown region will be called as reverse saturation current. So in this region, breakdown region, the Zener diode will work. So let's see the representation of the Zener diode. Zener diode will be represented like this. So the current flowing through it is IZ. IZ means Zener current, and the voltage across the Zener diode will be called as VZ, that is voltage. Now this Zener diode working in the breakdown region will be of two cases. First one is if the breakdown voltage is less than 4 volt. If breakdown voltage is less than 4 volt, we can call it as Zener effect. If the breakdown voltage is less than 6 volt, we also know that as the voltage decreases, it will sharply decrease. So 4 volt means here, 6 volt means here, that like. As the breakdown voltage will be less than 6 volt, then we will call it as avalanche effect. Now let's consider a circuit to display the Zener diode operations. So let's take a voltage source called as Vs. Vs means voltage source, and a Zener diode. The current flowing through the Zener diode will be called as IZ, that is the Zener current, and voltage across the Zener diode will be called as VZ. Next, when the voltage will be applied, the current will be production, that is because of the source. So it will be called as source current. When the current will be passing through the Zener diode, there will be no resistance right here. So there is no resistance. Therefore, if no resistance is given in series, to Zener diode, then high amount of current will flow through them. This may damage them. This may damage the Zener diode. To avoid this Zener diode, we will be implementing a resistance. So let's redraw the circuit. So in order to reduce the damaging of the Zener diode, we will add a resistance in series. So I will call it as RS because voltage Vs, current Is is flowing through it. So I will call it as RS. This is current Iz and Vz. Now let's add a load resistance in parallel to this Zener diode. Load resistance in parallel to Zener diode. So the resistance is load resistance and the current flowing through it will be IL. IL means load resistance current. So now we can know that the total current is Is, that is 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 flowing, and when it come to this point, some amount of current will flow through the Zener diode, that is Iz, and next another some amount of current will flow through the load resistance, that is IL. So we can say that Iz plus IL is the total current. Is is equal to Iz plus IL. Now we must be knowing about the VTH value. So what is the VTH value? VTH value is the whole voltage which will be circulating around this circuit. So this VTH value must be greater than Vz value. In this condition only the Zener diode can act in the breakdown region and do the voltage regulation job. So while designing VTH is equal to, VTH will be around this part. So what is the resistance near it? That is RL. So RL divided by what is the total resistance in this circuit? RS and RL are there. So both are in series. RS is series in RL. So RS plus RL into what is the source voltage? Vs. So this VTH value, which is equal to RL divided by RS plus RL into Vs, must be greater than Vz. In this condition only we can further proceed for the voltage regulation activities. So now if they give the value of VTH, we can easily find the value of Vs. If they give the value of RS, that is series, that is a source resistance, we can find the value of the load resistance. Like this, if they give the problem, we can use this formula. Now another three formulas we need, that is what is the value of IL, that is the current flowing through the load resistance, the current flowing through the Zener diode, and the total current Is. We also know that total current Is is equal to Iz plus IL. So therefore what will be the value of IL? Where IL is flowing? IL is flowing through the load resistance RL. Therefore we know Ohm's law. What Ohm's law says that V is equal to IR. But we need the formula of the current. So current I is equal to V divided by R. So which current we are finding? IL. IL means load current. So load voltage divided by load resistance. But we not have load voltage. So what we will do is, the voltage which is parallel to the load resistance, we will take the value of that as VL value. So Vz is parallel to RL. So Vz divided by RL will be the value for the IL. IL means load current. Next, Is. So what is Is? Is is the total current. So the total current is flowing from Vs towards Vz. Vs minus Vz divided by, what is the resistance in between Vs and Vz? Rs. So Vs minus Vz divided by Rs is the formula for Is. I already said Is is equal to Iz plus IL. We knew the formula for IL, we know the formula for Is. To find for Iz, what will be it? Iz will be equal to Is, if I send this IL to left hand side, minus IL. So this is the formula for Zener current. Iz is equal to Is minus IL. Hope you understood the concept of Zener diode as voltage regulator. If you have any doubt, please comment below. If you like the video, please subscribe for more engineering related topics. Thank you.